Hi everyone, my name is Charlie Wilkerson-Kemp, and today I'm talking about in vitro fertilization, also known as IVF, and how genetic testing, specifically pre-implantation genetic testing, or PGT, helps evaluate embryos before they are transferred. So what is IVF? It is a process where fertilization happens outside of the body. Eggs are collected, fertilized in the lab, and then the embryos are grown for several days. Once the embryo is then chosen, it gets transferred into the uterus, and IVF originally focused on infertility. That's what it was mainly used for when it first became popular. But with genetic testing now, it has also been able to prevent hereditary conditions. And then I just have a little infographic on the side talking about natural conception and when it fails and how the road to IVF kind of happens. And then some basic discoveries, methods for egg retrieval, implantation, and how fertilization happens outside of the body. So why add genetic testing? Many embryos naturally have genetic issues, especially with chromosomes. So PGT analyzes a small sample of DNA from the embryo before transfer. This helps identify embryos with normal chromosomes or those free of inherited mutations, which can improve the chance of the success rate and of a healthy pregnancy. So there are three main types of PGT. PGT-A checks chromosome number and identifies euploid embryos. PGT-M looks for specific single gene disorders when parents are carriers. And PGT-SR detects unbalanced chromosome rearrangements in families with known structural issues. So each type helps determine which embryos are genetically the healthiest. So the IVF and PGT process follows clear steps. First is ovarian stimulation to produce multiple eggs. Next is the oocyte retrieval where the eggs are collected. Then fertilization happens in the lab, either through regular IVF or ICSI, which is when one sperm is injected into an egg. And the embryos are cultured to the blastocyst stage. And then at that point, a trophectoderm biopsy removes a few cells from the outer layer, which would be part of the placenta to help the embryo grow. So those cells then go out for genetic testings while the embryo is frozen. And then after the results come back, a healthy embryo is chosen to transfer. So what do we learn from PGT? It gives information that we can't get looking from at an embryo from just under a microscope. It identifies chromosomal abnormalities, inherited mutations, and mosaicism. This helps determine which embryos are most likely to implant and to continue developing successfully. And then I just have some things talking about the mosaicism and what that means. For some real-world uses, PGT is used in several real-world situations. One is the likelihood of chromosomal abnormalities increasing with age. So PGT-A helps identify embryos with normal chromosomes. The first kind of graph I have here talks about the correlation of the risk of Down syndrome increasing with the age of mothers. And then another is for parents who both carry recessive genetic mutations. So PGT-M can find unaffected embryos. So there's a 25% chance that a child will be affected. And then there's another 25% chance that a child will be completely unaffected. And then a 50% chance that the child could be a carrier. So it's also helpful for people with recurrent pregnancy loss, since many miscarriages are chromosome related. And for individuals with structural chromosome rearrangements, PGT-SR identifies embryos that didn't inherit an unbalanced version. So genetic testing brings up some ethical questions. Selecting embryos based on genetics can raise concerns about disabilities, the limits of reproductive choice, and the use of newer ideas like polygenic screening, which is still pretty controversial. But because of this, counseling and informed consent are important parts of the process. So this infographic here just kind of talks about the, risks of excessive embryos and cryopreservation risks and bad health standards. So where do IVF and PGT stand today? IVF with PGT is widely available and considered one of the most accurate gold standard ways to evaluate embryos before transfer. Biopsy-based testing is still the most reliable method, and non-invasive PGT is being studied, but accuracy is not consistent enough yet. And as genetic technology improves, IVF continues to become more precise and informative. And these are my references. Thank you.